In this lesson, we're going to take a little bit of time and look at just the metric system and converting units within the metric system. I find it helpful sometimes to break them up. Um, it can improve clarity a little bit, and then we'll do one final lesson where we put everything all together. So converting metric units. We're going to use some examples to do the conversions, but before we go through the examples, I want to take a look at this measurement chart over here to the right. So the metric system uses a number of possible base units. You'll see meters, liters, grams, volts, watts, ohms. Um, it's not unusual to see amperes as another possible base unit. So there's a large number of base units that we can use. You'll see the example here. If we look at the base unit, 1m, it would be meters. So I've based all of my examples off meters, but we could replace this small m here with capital L for liters, B for volts, G for grams. There's a large number of units. It could be pascals we're talking about, depending on what particular course you are. So these prefixes are widely used for a number of different units. So now I've paraphrased a little bit of the chart. I've condensed it, and you will notice as you look. So let's work our way up the chart. So 1 meter is 1,000,000 micrometers. 1 meter is 1,000 millimeters. So the step from micro to milli, there's 1,000 less teeny tiny parts. As we go from micro to milli, you'll notice 3 decimal places in between these. So to go from micro to milli, we'd be dividing by 1,000. Okay, so that would take 3 zeros off and leave us with our 1,000. To go from milli to the base unit of a meter, we're going to have to divide by 1,000 again. You'll notice there's 3 zeros that we're losing as we go to the meter. Now, as we work our way up, I flipped the way the chart's written because I think it's a little easier for us to read. Kilo stands for 1,000. So a micro is a millionth. Milli is 1,000th. Kilo stands for 1,000 of. So when we see kilometers, it just means 1,000 meters. That's that grouping. And then we see mega, it's 1,000,000 meters. Now, we typically wouldn't see megameters. We'll talk about how many 100,000 kilometers something has. We could use megameters as an alternative, but it would sound very strange to us. But one place that we use meters is we often will use meters when we are, often use the word mega, not so much in meters, but when we're discussing, say, computer parts, when we're discussing watts. They talk about a wind turbine, how many megawatts of electricity it can generate. Electricity uses kilowatts. We'll see milliamps. You can see kilo ohms, you'll see all of those different things. We're used to seeing kilograms, that's a common one. Milligrams, that's fairly common for everyday use. And when I worked in the chemistry lab, when I dealt with really small quantities, I used to use micrograms and microliters, especially when I was working with drug design. So these are units that are kind of interchangeable, and that's one of the beauties of them. So I'll show you how to use this chart, but basically each step as we go up this chart, as we move up, the unit that you see, so is 1,000 times bigger. So a milli-unit is 1,000 times bigger than a micro. The base unit is 1,000 times bigger than a milli-unit. A kilo unit is 1,000 times bigger than the base. And then when we have mega, we're 1,000 times bigger than kilo. Going down, we're consistently getting 1,000 times smaller. So the unit is getting smaller, so there will be more of those pieces in the unit. Okay? Now there's a couple of units that I skipped, and I wrote them out separately just because I wanted this nice 1,000 jump in between each of the common units that we use. One of the units is centimeter. So if you think cent, there's 100 cents in a dollar. even though we don't have pennies anymore. Cent always means 100, so we took centennial anniversary, 100 years since something. So 1 meter has 100 centimeters. Another good one to remember is there's a step of 10 between a centimeter and a millimeter. I would suggest memorizing those two separately, and then you can kind of use the charts for the other ones. These units, I'm going to throw a star beside a couple of them, but there's a couple of these units that you shouldn't even have to think about. And I'm going to make a couple marks here on them as to which units I think really you should have memorized. You should have that one memorized, this one, and these two. I think those are essential for mega and micro. You can use them when you get to them, but the other three you really should have locked in your memory. So let's start with an example. We want to convert from 5 kilometers to meters. Now there's a couple ways to do this. I'm going to use the unity fraction again. So we're going to multiply by a fraction that's equal to 1. I want to get meters, so I'm going to put the meter on the top and the kilometer on the bottom. Now I need to figure out how many meters are in a kilometer or how many kilometers are in a meter. So let's look at our chart. 1 kilometer is 1,000 of the base unit. So 1 kilo unit is 1,000 of the base unit. So I'm going to put my 1,000 with the base unit and my 1 with the kilometer. So 5 kilometers is equal to 5,000 meters. Now, oftentimes I won't bother writing the math out this way. I know that going from meters to kilometers, there's 1,000 of these small pieces in this larger unit. So typically what I will do is I'll see my 5 kilometers. The decimal for that would be there. We want to move that decimal to make this number larger. This is a large number of small pieces in a kilometer. We're going to move it 3 places because there's a difference of 1,000 between them, and multiplying or dividing by 1,000 will move our decimal 3 places. The number needs to get larger because there is 1,000 of these very small meters in a kilometer. I say small meters because a meter is very small compared to a kilometer. So moving that 5 places, 5 kilometers must be equal to 5,000 meters. Okay, so that gives us 2 different methods to work with. Let's do the next one. We want to convert 3.65 megawatts into watts. Now you can write it out like a unity fraction, or we can move our decimal. So we're going from mega down to a base unit. Now we know this is a base unit because there's no prefix. Okay, the other thing is this W stands for watts. So the M must have been the prefix and the W is our unit. So we're going to our base unit. So when I'm going down to the base unit, I'm going down 2 blocks. So I'm going 1,000 and then another 1,000. Okay, so every time I move by 1,000, I'm going to move my decimal 3 places. Now, do I go left or right? Well, mega holds a lot of small stuff. The base unit is smaller than the mega unit. Well, you can see that from looking up here on our chart. There's 1,000,000 of the base unit to 1 of mega unit. Find my pen here on the chart. So we're going to go by 1,000 twice. So the first 1,000 is going to move our decimal 3 places. 1, 2, 3. The second 1,000, 1, 2, 3 more. So this is equal to 6. Put a 3 in here first. 3, 6, 5, and then we'll put zeros in the rest of the space. So 3,650,000 watts. Okay. You could have also wrote that out just by following through with writing out a unity fraction. Let's do a couple of more. In this case, we have 24,560 millimeters, and we want to go to meters. Now, this is something you would see in carpentry. They see this on their blueprints. For some of you that deal with manufacturing large things, or if you have large items you have to measure, 2,560 millimeters, that would often be used on a metric print. Part of the reason for using millimeters is millimeters gives us really nice precision, but we don't have to have a decimal because they're really easy for a decimal to get lost in printing or maybe miss being seen. So I think that's the reason why millimeters are often used on prints rather than using a larger unit of a decimal. So we want to convert this into meters. Now, I don't know if you're like me, I find this very difficult to visualize, but if it was in meters, I can kind of get a better idea of what that might look like. So let's look at our chart. We're starting at milli, and we're going to meters, which is our base unit. We're doing a step of 1,000. We're moving up the table, so we're taking some small units, and we want to write them as a larger unit. Now, if milli is really small and we're going to meter, that must mean our number will have to get smaller, so we're going to have less of the larger unit. So this step was 1,000, so we're going to move our decimal 1, 2, 3 places. 3 places to make the number smaller. 24.560 meters. Okay? Sometimes it's a little hard to explain these, so if you have questions, please don't hesitate to ask me. Sometimes it's hard to take something that I've done so often and put it into words for somebody that perhaps struggles with it a little bit or is a little less familiar. So please don't hesitate to ask any questions. Shoot me an email, give me a phone call, whatever it happens to be. Now we have 3.5 kilo ohms. We want to convert those into ohms. This little symbol is a Greek letter for ohms. If you're doing any kind of electrical stuff, I think carpentry is the only one that won't see these. So 3.65 kilo ohms to ohms. We're starting off at kilo. I'm starting off at kilo, and I'm going down to the base unit. So going up the chart, I'm going to write that as just a note here. Going up the chart, we're going to move the decimal left. Okay? When we go right, going down the chart, we're going to move the decimal left. Did I say left? I meant right. Sorry, I cannot think lefts and rights when I'm saying something else. I have a left-right dyslexic tendency, and you'll have to bear with me. Sorry about the long pause there as I think through and flip things around a couple times. So we're starting with kilo and we're going to ohms. Every kilo ohm has 1,000 of the smaller ohms. So we're going to move the decimal to make the number larger. There's going to be a lot more of these small pieces. So 3.5 kilo ohms is equal to 3,500 ohms. If you can't write that fancy omega, just write the word ohms. Okay. You'll notice the decimal moves by however many zeros there are in the question. So or the difference in the number of zeros. So if you're going from kilo to mega, there's just 3 decimals there. All right, we want to convert 3.3 millivolts to volts. So 3.3 millivolts. Milli is our base unit, it's the little m. Notice little m is used for meters and milli, so you kind of have to look at that. You will never have a meter volt, it's a millivolt. So we're going from millivolts up to volts. So we're going from milli to the base unit. We're doing one step, so that means 1,000 or 3 decimal places is what our decimal is going to move. And going up the chart, our decimal moves to the left. So we're going to move it 1, 2, 3 places. So when you write this out, we're going to start with 0. Put zeros in for these 2 spaces that you moved where there's nothing, they're placeholders. 3, 3 volts. Now, oftentimes the reason why we use milli is to avoid all these extra little decimals and all these extra zeros in front. Takes less space to write and can be a little easier to see. Convert 46 centimeters into meters. So 46 centimeters. Well, we have here, there's 100 centimeters in a meter. So 46 divided by 100 is a 0.46. Moving 2 zeros means we move our decimal 2 places. We're dividing, we move left. When we're multiplying, we move right. So 0.46. And we've got one final example to work through. Oh, I guess I've got 2 more examples to work through, sorry. Convert 33 millimeters into centimeters. So looking at our chart, 1 centimeter has 10 millimeters. So we're going to do 33 divided into groups of 10 to find how many centimeters. Our decimal moves 1 place for 3.3. Throw a C in there, 3.3 centimeters. Question 8, convert 4,560 microamps into milliamps. Okay, so I'm going to take microamps, we're going to convert into milliamps. So in order to do this one, we're going from micro up to milli. So we're going one step. One step, you'll notice there's a difference of 3 zeros. So it's going to be 1,000 in between them. So we're going to move 3 places. And the question is it going to be left or is it going to be right? Well, a milliamp, it's like a millimeter. It's a larger piece. So a lot of micro units will fit into one of the milli unit. So when we go up, our number is going to get smaller because the piece, the size of the pieces got larger. So in order to make the number smaller, we take our decimal and we move it towards the left. 1, 2, 3. So 4,560 microamps is the same as 4.560 milliamps. Okay? Or you could have written that out as divide by 1,000. We could have done some unity fractions. Just a couple ways to write it. If you're stuck and what I'm showing you isn't working for you, easiest way to handle that is to talk about it. So please get in touch with me and we'll figure it out together. Alrighty, and this one. A ladder measuring 6 meters from the ground to the top measures 6 meters from the ground to the top rung. If the rungs are spaced 30 centimeters apart, how many rungs are there on the ladder? So the thing to watch for in word problems when we have conversions is we have meters here and we have centimeters. Now when we do math with units, we usually want to match all of the length units or the types of units together. In most cases, unless you're doing physics courses where we keep units separate. Typically for our math courses, we want to keep our units the same in a question. So in order to find out how many rungs, I need to know how many 30 centimeter spaces there are in 6 meters. So I probably want to make my units match. So the ladder equals 6 meters, and the rung space equals 30 centimeters. So let's turn that 30 centimeters into meters. Well, there's 100 centimeters in a meter. So we're going to move our decimal 1, 2 places. 0.3 meters. I'm not sure what's going on with this pen. Okay, now let's say you could use logic to see if this makes sense. A meter is about the length from your nose to the end of your fingers. 0.3 of a meter should make sense that the space you would have to step up a ladder is smaller than a meter. If you went the other way, you would get 3,000 meters. 3,000 meters should not make sense to you when you think about it as a ladder. That would be one massive step. So use a little bit of logic to see if you've converted correctly. Now we need to calculate. So I'm going to take 6 meters. I'm going to divide it into 30 centimeter spaces using the meter conversion. So 0.30 meters. And we get 20 runs or 20 steps up. Clearly, we're not going to the top of a turbine here. There's not enough steps there. One last question. Stakes are placed 120 millimeters apart around a foundation. That measures 46 meters in length. How many stakes do you need? So we're going to go around a foundation. It's 46 meters. Again, we want to convert our units to be the same. So the space equals 120 millimeters. And then the length is 46 meters. So I would argue this is the best one to change. But it doesn't really matter. We could turn this into millimeters too. I'll typically change the space and I'll say, well, this is equal to millimeters, so 1,000 millimeters in meters. 1, 2, 3, 1, 2 meters. So that's every 0.12 meters we have a stake. I can't remember if this is the actual number for when we do concrete foundations or not, but it just made it work for the question. So in 46 meters, how many spaces are there that are 0.12 meters apart? Well, we're going to divide, and we will find that it is, I'll just get my decimal here, 46 divided by 0.12 leaves us with 383.3 spaces. Now we have to decide which way to round, because part of a space doesn't really, you can't have, or sorry, the spaces should be stakes. How many stakes? I'm thinking of it going around, so we don't have to worry about adding extra. So we could argue either way. We could either argue for rounding up to the next space because the distance might be a little too much, or you could argue to round down. This is one where I would accept 383 or 384. It won't be until we get to dealing with the questions in context that we'll be able to really determine that. But you could argue both ways, and I would have to accept your answer. So that gives us some of the basics of converting in metric units. It gives us a variety of metric units to work through. For most of you, I think you'll find the metric system typically easier. Sometimes that depends on age. The older you are as a student, the more difficult the metric system may be for you. That's pretty typical. But please let me know if you have any trouble with this section, and we'll get you all fixed up. And it shouldn't take too long to get you on track. If there's something that just isn't making sense, or you need some clarification, I don't mind doing even a mini class covering a few of these topics.